Hi, in this video I will show you how you can make an machine learning model and exploratory report based on any of your data sets using fastbenchmark and Google Colab. So we are at fastbenchmark.me at Google Colab section, and here is a link to GitHub repository. Let's move to the repository. So we need to clone this repository and to install all the requirements, and after that we need just to follow those instructions here. So let's do that. I just cloned the repository here and install all requirements. So the requirements are the following: so NumPy, Pandas, and PyQt. This PyQt is for the app. So here is an app, we can run it, and we need to find our data set. I will use the built-in data set which is in data path. So let's take this one, and we need to find the variable which we want to predict. So here is in insurance data set, and we will try to predict charges, which mean how much we will pay to clients based on his age, gender, BMI, amount of children, and so on. So let's try to build a model. We want to predict charges. And charges are from small to very large numbers, so the logarithmic metrics will be better than just root mean square error. So we can also configure variables. So if we see that some variables contain too much NaN values, we can just unselect it. But here everything is okay. We will use all the variables. So okay. And all we need is to generate a report. So it's in a report path now. So let's go to that path and we see our report. Now we need to go to Google Colab and upload our notebook. So it's in reports, it's here. And we also need to add our data set, because as we can see here, we will use it here. So it should be in Google Colab. So just push upload, find our data set, it's here. So we are done. Now we can just run it and look through that report. So here is how our data looks like, our variables looks like. Here is the very useful plot which shows us the dependencies between all our variables, and some useful functions and variable statistics here. So here is our target variable, and here is a logarithm for that. As you see, logarithm is much more normal distributed than non-logarithmed. So logarithmic metrics was a pretty good choice. So we also have a lot of functional here to make our model better. So let's look at the final check and the final score here. So we have a score of about 0.38 And let's look at features. So the most important feature was BMI, a bit less important is age, and so on. So we can try to, for example, tune our model. So let's just open this one. Here is the code which will tune the model, and all we need is to change, as you see, use true to use model tuner. So let's use model tuner. So after that we should rerun everything. So we also can use the category tuner. Here is the description, and we can use some feature engineering here. So for example, if you want to make some custom features, you can just make it here. So for example, if you want something times something, just use it like this, or maybe you want to make something divided by something, or maybe some more strong formulas with more features in it. That's all you can do here. And you also can make automatically generated can use automatically generated variables. So it would be everything divided by everything, or everything times everything, and some squares and so on. So there will be a lot of features, and it will take a bit more time to make a model, but it could make a model better. And let's look also at our variable statistics. So for example, here we have age variable, which is numeric. And okay, so let's look at categorical also. So here is the distribution, and here is the distribution of our target variables in terms of our here it calls sex, but it's actually a gender variable. So for numeric it would look like that. So we will see only that variable distribution and the distribution of its logarithm, and so on. For any of those variables we will see all the statistics. And also we can look at the error statistics here. So it will help us to understand which values of those variables will give us the largest error, and maybe it will help us to analyze something here. And as we are done, let's look at the model tuner. It's here. So what did that model tuner? It tried different tree methods. It tried different subsamples to train the model, and different depths, different alphas and gammas for some source of regularization and so on. And here we have our final check, and as the C, it was 0.38 or something, and now it's 0.34. So just only this model tuner, only this one of a lot of functions, it made our model much better already. So if we will use all of those functions, we could make it better also, but it could take some more time. So actually this report got those comments here everywhere, so you can just inspect it and try to use different methods, try to make some new super features and so on. And all of this is already generated for you, so you will work with some sort of benchmark. That's why our project called fastbenchmark, because you got this benchmark very fast. And all you need is this repository, clone this repository, install those requirements, and you need to have a login in Google Colab, and you can use it already. So you need a dataset and fastbenchmark, and you got this beautiful report with a model and a lot of functional to make your model better. And I think that will help you to do data science and machine learning, and it will help you to make data science fun again. Thank you.